Hello all, I want to welcome you back to our lecture. Today we'll be looking at solution concentrations. The basic theme of this class will be, we're going to be looking at how we can quantify concentrations of solutions that we've introduced in the previous lecture. And let's take it up from there. As usual, I have a beautiful quote here. This is from Elon Musk, a popular figure in the United States. He says, "Patience is a virtue, and I'm learning patience. It is a tough lesson." I'm not going to say anything much about this, but it's a good quote that you can ponder about. All right, let us get straight into the learning. In this class, we'll be achieving just one lesson objective. What would that be? We're going to, at the end of the class, we're going to know and understand how to do calculations in unit of molarity, unit of percentage weight by weight, percentage weight by volume, and percentage volume by volume. And let us take it up from there. Solution concentration. Solution concentrations simply express relationship between the amount of a particular solute and the given solution with respect to the solution itself. You see, remember I told you earlier that every solution, let's say solution, simply is solution simply means a solute plus a solvent. Now, so in solution concentration, we're looking at solute as a fraction of the solution. So the solute here is a fraction of what the solution is all about. So how much of this solute is in the entire solution? And there are two ways we do that. The first one is the molarity. Molarity expresses moles given in a liter of solvent, and the molarity is M, and the formula is the moles of solute over the liters of solvent. Most times the volume is measured in mils, but you have to convert that volume to liters and then plug it in this equation for this equation to work correctly. And secondly, we can also express concentrations in percentage concentration. In percentage, because there are actually three of them, but we're going to talk about them by the time we get there. So it expresses the amount of solute in 100 parts of a solution. So it's typically a fraction of a solution, but this time we're expressing it as a percentage. Now let's take it off from there, from problems immediately. Here we're going to be solving a lot of problems. As usual, if we solve a lot of problems, we're going to use this practice to understand the concept better. It says, what is the molarity of a solution that contains 0.598 moles of sodium chloride in 350 ml of a solution? Now listen, again, I want you to let me put it down. Molarity is a conversion factor. We're going to, just like we use this as a conversion factor and moles as a conversion factor. In this case now, molarity is a conversion factor. Because if you look at it, it's made up of moles over liter. So we can use it to always convert, but it's a conversion factor for moles and liters of solution. We're going to always use it to do that. So anyway, let's solve this problem. We're looking for the molarity. Remember, molarity M is giving us moles over liter. That's what we have. Now, we have the volume given in mils. What that simply means, we need to convert it to what? We need to convert it to liters. And then we have our moles. We're going to plug it in. So converting that 350 mils, if I convert it, it's going to be, of course, you need to have memorized this now. A liter is equivalent to 1000 mils. And when you do your cancellation properly, you're going to actually get 0.35 liters. That's exactly what you get from that problem. Then we'll now plug it into the main equation. This will now be 0.35 is the liters. The mole is given to be this. So put the mole on top. 0.598 mole divided by 0.35 liters. And when you do your, put this in your calculator, you're going to get 1.7, of course, moles per liter. Or if you don't say moles per liter, you can say 1.7 molar. That is what it gives us. You can always feel free to pause this video, practice these things, and always get back to them and see if your answer is correct. In problem 2, another dimension now, it says calculate the molarity of a solution made by dissolving 18.4 grams of potassium carbonate in enough water to make a 250 ml solution. That's what we're asked to make here. So now, we're not giving the molarity, but we're giving the mass. Remember, it's easy to convert from mass to molarity using the molar mass. That's what we're going to do. So first, let's calculate the molar mass of potassium carbonate. If you calculate the molar mass of this, use a periodic table. The mass of potassium is 39.10, and there are 2 atoms plus oxygen. We have carbon is just 12.01, plus there are 3 atoms of oxygen, and oxygen is 16.00. And if you add everything together, you're going to get 138.21 grams per mole. Now, there are 2 ways we can solve this problem like before. You can always convert this to mole and then use it. So I'm going to do that one first. So I'm going to now convert. Remember, we have this in mil, so we don't want it in mil. So we're going to convert it to what? Again, we're going to convert this 250 mils. You want to convert it to liters. 1 liter over 1000 mil. And this is going to give you 0.250 liters. That's what we have here. But we're not done. We have the molar mass. We've not converted this mass to what? We have to convert this mass to mole. We're going to use molar mass to do that. So let's start. The mass given to us is 18.4 grams of potassium carbonate. Of course, 1 mole of K2CO3 will give us the molar mass 138.21 grams of K2CO3. And again, if you cancel out everything here, you find out that you only have the ones you need. And of course, the answer here is going to be 0.133 mole. That's what we have here. Now, but we're not done. That's not the answer. We're not done. We're not done. Remember, we now have our liters, we have our mole, so we need to plug it into the formula. So if you plug it into the formula, it's going to be molarity. Finally, it's going to give us the mole, 0.133 mole, divided by liters, 0.250 liters. And then, if you do your math well, in your calculator, that will give you 0.53 molar. 0.133. Let me put that in my calculator. 0.133 divided by 0.250. That will give us 0.532 molar. Molar is capital letter. Now, you see this problem now. You can also do this in one soup. Let me show you that a little bit in this box. Alternatively, you don't have to, depending on the one that works for you. So I'm going to use a different color. What color am I going to use? Okay, let me use just blue to do this. Okay. If I want to do this in one soup now, what it means, I'm going to start from my grams. I'm going to keep putting everything together until I get it to molarity. I can do that. You can do that in one single soup, and let us start. So you can do it whichever way that works for you. If you feel this is long, you don't have to do it. You can always do it in this way. But I tell students, there's a way to always do it. So I can say, okay, let me start. I can say 18.4 gram. I'm not going to put the name of the compound. I'm just going to make it easy. Let me just draw a long multiplication line. I want to convert this into 1 mole will give me 138.21 grams. Now, if you cancel this and this, we have it in mole. But that we want it to be in liters, right? But remember, we have it in mole. So what I'm going to be looking for now is to do liters. How do I do liters? My liters, if you look at the formula for molarity, where's the formula again? Molarity, of course, remember, molarity is moles over liter. So what it means, the volume is always down. So we're going to find a way to make the volume down. What is the volume do I have? 250. So I'm going to put it down. I'm going to say, if I flip that, I'm going to say 1 over 250 mils. Nothing is cancelling here, of course. Nothing will cancel here. But I don't want it to be in mils. I want it to be in liters. So what do? I can remove these liters. Of course, 1000 mil will give me 1 liter. Mils, this cancel this. And what do I have now? I have moles on top, I have liter on the bottom, and this becomes my answer. If I decide to put everything in one soup, so when you do your answer again, you're going to get that. And put it into my calculator, and then when you do it again, you're just going to get 0.532. So that's what you're going to get. You're still going to get 0.532 molar. So this is an alternative choice in this box if you decide to do it in one swoop without breaking it down into pieces. Let's go to the next problem. It says, what mass of calcium chloride is needed to prepare 225 ml of this guy? Go back to my red. So what are we going to do? First of all, we have the mass given. So we're looking for the mass, right? That's what we're looking for. So, and if you're going to get the mass, you need the mole first. So we can get the mole from here, from these two. We have molarity. We have, remember, molarity is what? Moles per liter. So if you get from here now, you can get your moles by solving for this. And from moles, you can get your mass. Let's calculate the molar mass of calcium chloride. So molar mass of calcium chloride is going to give me, calcium is 40.08 plus chlorine is 35.45. If you add everything together, it's going to give you this. Now, again, we're going to be using molarity as a conversion factor. I'm going to do this in one swoop case. That's what I want to do. So I'm going to, like I just showed you in the second alternative, I'm going to do that. I'm going to do it in one straight case. Let's see how that works. So first of all, I'm going to want to convert these moles to mole using molarity. Remember, molarity again is our conversion factor. Molarity is a conversion factor. I'll keep saying this because the emphasis helps a lot. It's a conversion factor. That's what I'm going to use. So I'm going to start from the male. So I'm going to have 225 males. First of all, I don't want anything to be in liter. I want to be in males. I have to convert it to liter. A liter is 1,000 mils. And of course, if I begin to cancel LA, this is what I have. And then have it in, now I can convert to moles using molarity. Molarity is what I can use in converting to moles. Let's see how that works. So what I'm going to do here now is that I'm going to say 4.50 moles over liter, because molarity means moles per liter over 1 liter. Again, if you look at this, let me cancel liter, we cancel liters, and then I have it in moles, but I don't want it mole, I want it to be in mass. So to convert it from mass, I'm going to use the molar mass. So, and to cancel moles, my moles has to be on bottom, which exactly is this. So this is going to be 11.098 grams over 1 mole. Again, mole, we cancel mole. And if you multiply everything together, your answer, you're going to be left to be in grams. And so the answer is going to be 112 grams of calcium chloride. That's exactly what you do. So basically what we did here is that I went from volume to from mils. So no, wait, I went from mils to liters. I went from liters to moles at this point. I went from moles to mass. That's exactly what, or to, let me just say 2 grams. 2 grams. That's exactly what I did here. So this is doing it in one swoop. But you can always do it in separate swoops by, first of all, calculating the moles by rearranging the formula. If you rearrange this formula, moles will be molarity times liter. And then you get that, and then later use it and multiply the molar mass to get the mass is going to give you the same thing. Problem 4. That is exactly where we are now. It says the concentration of sodium chloride in blood is 0.150 molar. Calculate the volume of blood in mils that contains that. Now, again, you look at this, we have the molarity, we have the mass, we're looking for what? The mils. But we need the moles, but we can get the moles from here, from grams. So first, let's calculate the molar mass of sodium chloride. So this is going to be, sodium is 22.99 plus chlorine is 35.45. When you add them together, it's going to give 58.44 grams per mole. That's what we get here. And the next thing we do, of course, we're converting here now, we're converting from grams to, that's the question, to mils. That's basically because it says in mils. We want it to be in mils. That's exactly want it to be in mils. So let's start. I'm going to do it in one swoop conversion. So I'm going to start with the mass. So I have 3.75 grams of sodium chloride, of course, but I don't need to write that. I want to first of all convert it to moles. To convert it to moles, I'm going to use the molar mass. So it's going to be 1 mole over 58.44 grams. And then if you cancel LA, it starts saying that you have it in moles. The next thing you want to do is, it says I have it in moles. I can use molarity to convert it to what? to liters. Now look at what is going to happen here now. If I say, remember this means 0.150 moles per liter. If I put it the way it looks like here, mole over liter, it's not going to work. It's not going to work. So what is going to happen? I have to flip this number. I have to flip it, because for it to work, I have to flip it to cancel my mole. So what am I going to do? I'm flipping this number. So if I flip this number now, of course, it's going to be 1 liter over 0.150 mole. So that's what I'm going to do. I'm going to say 1 liter over 0.150 mole. And if you look at it, if mole cancels mole, you're going to have it in liters first. So you went from, remember, went from grams to moles, from moles to liters. We're not going to go from liters to mils. Of course, what conversion are we going to use? Remember, you want to remove liter. A liter will be 1,000 mils. Again, if I cancel liters to liters, all my answer, okay, I'm going to take away that. I want to use blue. Liters to liters, and I'll be left with everything. If you multiply it, it's going to give you 428 mils. So basically what it did here was we converted from grams to mole using molar mass, from mole to liters, and from liters to mils. That is exactly what we did here. Yeah. So note again that for you to convert to volume, from using molarity, you have to flip it so that the volume, or rather the liter, will be on top and the moles will be on the bottom. And that's exactly what we did at this point. The next problem. Okay, we're done with problems in this molarity aspect. For now, we're going to look at types of percentage concentration. You see, there are 3 types of percentage concentration we'll be talking about. The first one is percentage weight by weight. In percentage weight by weight is simply expressing amount of solute in 100 grams of the solution. So it's simply, weight by weight is simply the solute mass over the solution mass times 100. So we're talking about the mass of solute over mass of solution times 100 over 1. Again, we also have the second one called weight by volume relationship. In this one, this is specific. It expresses the grams of the solute contained in 100 mils of solution. For this formula to work, for weight by volume formula to work, the grams, or rather the mass, must be in unit of grams, and the solution must be in unit of mils for this to hold true. And the last but not the least is percentage volume by volume. In percentage volume by volume, it can be of any unit, it doesn't matter. What matters is that the unit of the numerator on top and the denominator should be same thing. So the unit of volume should be same thing, so that it cancels completely and give you just a percentage fraction. So this is solute volume over solution volume times 100 over 1. Now let's just put this into work. That is where it begins to make sense for us. It says calculate the percentage weight by volume of a solution prepared by dissolving 8.97 grams of lithium nitrate in 250 ml of water. Now this is weight by weight. Remember, weight percentage, let me write it. Weight by weight is solute mass over solution mass times 100. So what would that be? The next thing we're going to do is, now we have our solute to be 8.95 grams, but our solution, we don't have it. But remember that solute plus solvent. So we have to add it together. We have our solute, but with this one, we have it in mils. What do? We can do something. We have the density of water. So we can convert this mils to mass of water. What do? Let's do that. So using density now as a conversion factor, we're going to convert 250 mils of water. Using density 1.00 grams over 1 mil. Of course, if you cancel, that's still going to give you 250 grams of water. Now, let me give you a secret for this class anyway. Now, it is taken because what we take the density of water to be unit, just 1.00 grams. It can always be seen that the 1 mil of water is equivalent to 1 gram of water. You can assume, if you assume that, it's still going to give you this to be in these grams. Now, having gotten this, what do we do? Now, let's look at our solution. What will be our solution? So, our solution mass will be addition of these two. So, it's going to be 8.97 plus 250. When you add that up, it's going to give you 258.97 grams. Now we have all we needed, so we'll now begin to apply it. So it's going to be percentage weight by weight will be 8.97 grams of the solid divided by the solution 258.97 grams times 100, and that will give us 3.46 percentage weight by weight. Always make sure you put this bracket weight by weight. That specifies the type of percentage. If you just say 3.6%, I don't know which one. Are you talking about weight by weight, or weight by volume, or volume by volume? It is good you make those specifications very clear. The next problem, it says if 5.00 gram of sodium iodide is dissolved in enough water to give 400 ml of solution, what is the percentage weight by volume? Remember what I told you? This is easy. This must always be given weight of solid over the volume of solution. So that's what we said. Remember that? So it is grams of, it must be in grams. So we say grams of solid over volume of solution, or you say ml of solution times 100. And if we do that, we have it in gram. Good enough. We don't have to convert. We divide that by the volume. We have the solution in mils as well. Easy for us. Then when you times this by 100, you're just going to get 1.25 percentage weight by volume. That is what you get, and that will be our answer. Let's take more problems as usual. A solution is made by dissolving 150 ml of methanol in enough water to give 2750 ml. It says determine the percentage volume by volume. Again, this is volume by volume that we're looking for, which is easy. Percentage volume by volume is simply volume of solid, or you can say solid volume. You just have solid volume over solution volume times 100. Now, if you look at this, you are dissolving 150 ml of methanol, so it's going to be 150 ml. You make a solution of what? 2750 ml. If you multiply this by 100, you're going to be getting 5.5%. Always feel free to pause this video and try out these problems yourself and get back to them and check them for comprehension. The next problem, problem 8. Now it says, what is the percentage volume by volume of a solution prepared by dissolving 38 grams of proper alcohol in water to give this number of solution? Now, so we're looking for, look at the question, so we're looking for percentage what? Volume by volume. That's what we're looking for. Of course, this simply means solid volume over solution volume times 100. That's what we have here. However, if you look at that, now we have the mass, so we have the volume of solution, which is granted, good. But we don't have this, but we have the density. So we're going to convert, we're going to use this 38 grams of propyl alcohol and convert it to what? Volume, to mils, using this density. And the volume of our, and the unit of our volume will be in mils because it's what we have here. So let's do that. So we're going to say that, remember, this density simply means 0.803 grams per mil. If you're solving for mass, this is okay. But if you're solving for volume, you need to flip it. It's going to be 1 mil over 0.803 grams. That's what we're going to do because we're looking for volume. We're going to use this conversion. So it's going to be 38 grams. If you multiply it by, of course, 1 mil, I want the mil to be on top, 0.803 grams. Grams, you cancel grams. And then this will give you 47.3 mils. Now, we'll now move on with the last. So if you now put everything in, we're looking for this. This is, remember, this is the solid volume. So that's what we're looking for. We didn't have it. 47.3 mils divided by 348 mils. Again, this, we cancel this. If you multiply this by 100, and this is going to give us 14% volume by volume. That is how you solve this problem. Always feel free to pause this video and try out these problems yourself, and always get back to them. The next one, it says, calculate the mass of lithium bromide that will be needed to prepare 300 ml of these. So now we're looking for, there are two ways you can solve this problem. I usually tell my students, there are two ways you can solve this problem, and this is weight by volume. Now assume, okay, I have to write this. Assume, this assumption is the best, that percentage weight by volume has a unit, is measured in, let me just, in grams over 100 mils. Assume that. This is a very good assumption. So what we're going to do, we're going to take this now, put it in this unit, and use it to multiply the volume. So typically what we're going to say is that you have 7.50. Instead of saying grams, instead of saying percent now, we now say grams over 100 mils. And then you multiply this by the volume given. What's the volume? 300 mils. Now if you look at it, it's legit. Mils, we cancel mils. And if you multiply this by this, it's going to give you 22.5 grams of lithium bromide. And this formula is very legit. Very, very legit. So make those assumptions, helps you to solve those problems. The next problem. Now we're getting to an end in this lecture, and it's been an interesting ride, particularly with a lot of problems we're solving. It says convert. So now this is an interesting problem. So we can convert percentage weight by volume to molarity. That's what we're looking for. But the first thing first, anytime we're talking about molarity, involves moles. Remember, molarity simply means moles per liter. Remember that. So let's calculate the molar mass of this. Sodium is 22.99, but we have two atoms there. We have two atoms of this guy. We have to multiply it by 2. That should be 2 brackets 9 plus 12.01 plus 3 brackets 16.00. So now if you add everything up, it's going to give you 105.99 grams per mole. Now, so basically, what we're going to be doing is to do a direct conversion. So let's see how we have. So remember the assumption again, and I'm going to assume again that this is, unit of this is grams over 100 mils. That's the assumption again. So let me start. If I have 1.25 grams over 100 mils, I want to convert it to molarity. That means molarity means moles per liter. I want to remove my mils. My mils will be, if I want to remove my mils, it has to be on top. It has to be on top. So this is going to be 1,000 mils over 1 liter. If you look at my mils, it's gone. I have my liter under, which is good. I want to remove grams or mass. How do I remove grams? I'm going to use the molar mass. So what it means, for me to remove it, my mole has to be under, which is good with this. So this is 105.99 grams over 1 mole. And look at that. Oh, this is not going to work. You see that? Can you see this is not going to work? Very, very good. So you can't be having this. What are you going to do? You have to put, it has to be under. So that is one thing good about using conversion factor. So it's going to be, of course, you want the mole to be on top because the mole is here. So this is going to be 1 mole over 105.99 grams. Again, let's see, grams, we cancel grams now, and that makes it correct. And then what do? We have moles over liter, and that is what we're looking for. If you put all these things together, you're going to get 0.118 moles per liter, or you can say 0.118 molar, capital letter. Now we're going to be going to the last problem, but not the least. Again, you can pause the video, try out these problems yourself, and come back and check it for comprehension. The last, it says convert 0.9900% weight by weight of sodium chloride solution to molarity. Again, anything molarity and you don't have the mole, remember you're going to calculate the what? You need to calculate the molar mass. The molar mass of this, we calculated it there. I'm going to copy it, 58.44 grams per mole. Now this question is different now. It says assume that the solution has a density of this, which looks like the density of water. Let's see how this goes. We're going to just use this as a conversion factor to remove something, possibly moles. Let's see. If you start from 0.900, now, I didn't say something. There's something I will have to say. Now, let's remember, there's another assumption that is good. Another assumption you can make is that this volume, percentage volume by volume, can be seen to be, it can be any unit, but in this case, I want to call it grams over 100 grams. That's an assumption. Remember, the one we did about grams per ml, we said grams over 100 ml. This is weight over weight. So we're going to say the unit assumption, this is an assumption, is that the unit will be grams over 100 grams. And this works correctly. Let's see. So that means we're going to put 0.900 grams over 100 grams. And then we'll start eliminating. How do we eliminate here first? You can eliminate anything first. We can eliminate the grams here using the density of this. So if I bring in the density, 1.00 grams over 1 ml. Look at this. Gram here cancels grams here. And then we still need to eliminate moles. How do we eliminate moles? And bring liter, because this is molarity. Molarity means moles per liter. Remember, we want to convert this thing to moles. Molarity means moles per liter. So bringing in liters is good. So to remove this, we have 1,000 mils over 1 liter. Mils cancels mils. We have it in liter. And our liter is on bottom, which is good for us. So what we need to do now is, how do we remove these grams and convert it to moles? You do that with the what? Molar mass, remember. So what is it going to be? Our mole is going to be on top. So it's going to be 1 mole. And then our molar mass is going to be down 58.44 grams. Again, grams cancels grams. And when you put all this together, you're going to have 0.1. So let me put this in my calculator. Divided by 100. 1,000 divided by 15.44. It's going to give you 0.154 molar. Okay, let me just first of all put it in molarity before I say molar, because that's where. So this moles per liter. So this is moles per liter, or 0.154 molar in capital. Once again, it has been an interesting lecture. Thank you for listening. We're going to put a stop at this end and try to always practice these problems, pause the videos, do the problems yourself, and then go back and watch it and check your answers. If you do have any questions, do not forget the Idria channel to contact me. And once again, thank you for listening. Have a wonderful day ahead of you, and bye.